Now today's class is on correlation. What do you mean by correlation? Co means both two things are related to each other, right? So we are judging the strength of relationship between two different items, right? Or you can say in a numerical sense they are two different variables. Now let us assume that variable can be x and y, boy and girl, height and weight, so many different things. Now when I talk about strength of relationship, the relationship strength is given by a value, particular value, right? And the thing is, it can be a positive value and it can be a negative value, right? So positive, negative, both values are possible. So numerically, we are judging the relationship. We are judging the interrelationship, right? Interrelationship, right? Strength of relation, right? That is, and it can be strength of relationship. It can be positive or negative, right? And what is going on through this correlation? We are trying to judge something, we are trying to predict something, the relationship based upon this variable. So we are interested in prediction due to this correlation, right? Due to this correlation we can predict so many different things about the variable trends, right? So this is all about correlation. Examples of this correlationship. So when I talk about relationship, a relationship could be beneficial, right? It could be beneficial, right? Or it can be harmful, right? Or it can be neutral, right? So suppose some of your friends may be very good to you, but not all friends can be good. Some of they are maybe jealous of you, right? They are trying to harm you, right? So this is a harmful relationship. While there are some friends who are living far in America, they have no role in your life, just hi, hello, that's it, right? So this can be called as positive. This can be called as negative, and neutral remains as such, right? So neutral is as such, right? So these are examples of the relationship. Let us see some examples of the positive relationship and negative relationship. All of you know I have given you the diameter and age of tree, right? All of you know there is ring formation in the tree, and each year there is a growth of ring. So it expands laterally, right? So more the age, the more the diameter of the tree, right? So this can be one of the positive relationship. They are related to each other, right? And this relationship cannot be negative, right? And the negative relationship can be other way around, right? You can devote so much of time in your social media, friendship and other thing, whatnot. Like hours on Facebook, you are keeping on browsing on Facebook and talking to random people or making friendships, then you will suffer in your exams, right? So hours spent on Facebook will reduce your marks. So this can be called as a negative relationship, right? So this is about positive and negative relationship. I hope you can understand, you can easily relate with this. Now let us see the calculation portion of the R value. R value is given as summation of product of variance divided by summation of product of standard deviation, right? So this is the formula for this, and if I calculate, if I extend it further, R will be sigma I is equal to 1 to n x minus x bar, since we have two values x and y, so y minus y bar. So this will be my numerator and my denominator will be sigma I is equal to 1 to n x minus x bar whole square, and so this will be the summation of sigma sigma 1 to n x minus x bar whole square into sigma I is equal to 1 to n y minus y bar whole square. So this is the formula, and there are three possibilities. R is plus, that means positive correlation. R is negative, then we have negative correlation, and R can be zero at times. This is called neutral correlation. But value of R ranges from, R is normally ranges from -1 to +1, right? So the values of R are ranging from -1 to +1. Sometimes it happens that neutral correlation comes up. So we are interested basically the relationship which is in positive or negative, right? All of us, we know that height and weight are related, are positively correlated, and we will record this using students of our class. So let us start with this. Let us record the height and weight relationship. For that we are measuring the height of this 10th roll number candidate of the class, and his height is 177. So I write here as 177 is the height centimeter, right? Now let us take the weight of the candidate, and let us see his weight is around 55 kilograms. So I write 55. Right. She is the second roll number, and her height is 163. So I write here 163 centimeter, right? And then let us take her weight is 76 kilograms. So I write 76 kilograms. Now onto the whiteboard. So we have written the roll number wise the student list, and we have recorded the heights of the students, and the mean value of height is 165.8. Similarly, we have recorded the weight of the students, and we have recorded the mean to be 53.9. This is deviation from, these are the deviation from x value, and this is the deviation from x squared. Now similarly, deviation from y value and deviation from y square. So the summation of deviation squared is 547.6. Similarly, deviation from y square is equal to 1766.9, and the product of deviation is written here. Now product of deviation is 368.8. Now on to the calculation itself. So we can see calculation is given as R is equal to product of variance x minus x bar, y minus y bar, divided by, whole thing divided by square root of x minus x bar whole square and square root of y minus y bar whole square. So if we calculate, the R value comes, R is 368.8 whole square divided by 547.6 square root of 1766.9. So the value is 368.8 divided by 983.5. So R value is 0.37, which implicates that the relationship is positive and it is weakly positive correlation.